Today we are looking at section 9.7, linear programming, and we're going to do that first by looking at a Desmos activity. You guys are not going to do it, you're just going to follow along online, and then we're going to do an example. So first of all, the objective for today, it'll show up in the Desmos activity, but we're just going to write it down first. So it says, I can solve linear programming problems in two variables using graphical methods. So with this is a real-world application of graphing systems of inequalities, and it's going to help us solve real-world problems. So if I look at this Desmos activity, and again, you guys are just following along, you can see the objective that we just talked about is at the top. But here's the problem we're faced with. You own a parking lot. There's a big event coming up, and your parking lot is going to be in high demand. You will be allowing both buses and cars to park in your lot for the event, and you want to maximize your profits. So in order to attack this problem, to figure out what would get me the most amount of money, I need to talk about different types of constraints. So you can see that this slide says there's an area constraint, meaning I only have so much space. It says a car takes up 6 square meters, a bus takes up 30 square meters. Your parking lot is 600 square meters. You will have valet parking, so you can pack the cars and buses in all of your available space. X is going to be cars and Y is going to be buses. Well, if each car takes 6 meters, that means it's 6x. And if each bus, so and would be plus, is 30 square meters, I would do 30y. But now the key here is that it's an inequality. So in order for me to write an inequality, the most space I have is 600, so it's less than or equal to 600. So that would be the area constraint. If you, on your notes, you can see that the constraints, slide 2 was the area constraint. We just said it is 6x plus 30y should be less than or equal to 600. Okay? So then we would have shared that with the class. Gone to the next slide. Now there's a valet constraint. It says your hardworking valet can only handle up to 60 vehicles. So combination of cars and buses, they can only deal with 60 vehicles. So once again, if X is the cars and Y is the buses, we know that X plus Y, no matter what combination of it is, has to be less than or equal to 60, because that's the most cars and buses that the valet can deal with. So again, if I go back here, we said that this was the valet constraint, and it was X plus Y is less than or equal to 60. Now on the next slide, what you're going to see is that there's also real-world constraints. So remember, the X represents the number of buses, and the Y represents the number, X is the number of cars and Y is the number of buses. Well, we have to think about what that means. So what has to be true about the X's? Well, I can never have negative cars. So my X always has to be greater than or equal to 0. And likewise, if Y represents a number of items, so a number of buses in this case, that's always got to be greater than or equal to 0. So when you're asked about real-world constraints, which you oftentimes will be, you're going to talk about your two variables, your X and your Y, and you're going to restrict the domain based on what they can possibly be. Okay, so we have basically 4 inequalities, and this goes back to section 9.6 where we started talking about graphing a system of inequalities. We're really going to graph all 4 of these things in the same grid. So if I look at that on here, the next slide shows that I'm actually going to start at the bottom, so we get to just fill it in, so you won't have this on here. But remember we said X is greater than 0. Notice that we know X is greater than 0, greater than or equal to would be a vertical line, and everything to the right is shaded. Y is greater than or equal to 0, again, that's up here. Really what the X greater than or equal to 0 and Y greater than or equal to 0 does is it restricts you to the first quadrant. Okay, so a lot of times you're going to just see us giving you the first quadrant. That's because of those real world constraints. Now, again, as we go through, you're going to graph these by hand. But if we graph this one, our first equation or inequality was 6x plus 30y is less than or equal to 600. And you can see that graph, that in blue here, it's shaded below. And then last but not least, the second one was just x plus y less than or equal to 60. So you can see if we graph all four of those things by hand, we are left with this bottom place that all those are, this is the one little spot where all four intersect. Now, the next thing says, write the ordered pairs of the corners of the feasible region. The feasible region is, again, where all of them overlap. Okay, so this point is one of the points of intersection, so that'll be 0, 0. This point is the second one, so 0, 20. This is the third one, and you can see it's 60, 0. And this is the fourth one, 50, 10. So once you write all your inequalities and graph them, those are the critical points that you care about, the 4 points of intersection or the points of intersection that make your feasible region. So we're going to go back to our note sheet and we're going to write those down. Because remember, the main question we're asking ourselves is how can we maximize our profit, meaning what combination of cars and buses would allow me to make the most money? And the answer is going to be one of those 4 points. So linear programming always allows us to maximize or minimize something, and the numbers we're going to be looking at are those 4 points that you find. So the next thing that you're going to be looking for in the word problem is how you make that profit. So in this case, it says you charge $10.50 for each car and $17.50 for each bus. And it says find the profit of at each of the 4 corners. But really, if we're going to make $10.50 per car, that's $10.50x and $17.50 per bus, that will be the expression I use. So when I go back to the note sheet, which is where we can end now, for this to make a profit, I'm going to use the equation 10.5x plus 17.5y. Now, these number of cars, number of buses are these 4 ordered pairs we got. So we could have 0 cars, 0 buses. We could have 0 cars, 20 buses. We could have 60 cars and 0 buses, or we can have a combination of both, 50 cars and 10 buses. One of those 4 answers will give me my biggest profit. So if it's 1050x plus 1750y, I would take 1050 times this plus 1750 times the second one. Now obviously that one's 0. This one again, 1050 times the first x plus 1750 times the second one. And that gave me $350, which isn't too bad. $10.50 times 60 plus $17.50 times 0 gives me $630. So I'd rather have all cars than all buses. However, if I did a combination of the two, so if I have 50 cars and 10 buses, I make $700. So you can see that that is the combination I want. So to answer this question, I would want 50 cars and 10 buses. That is how I would maximize my profit. Okay? All right, so that Desmos activity was supposed to kind of walk you through how to lay these out, but that's what we're doing. We're maximizing or minimizing something using this. So now let's do the second example together. Claire Dunphy decides to have her company make new closets to help maximize her profit. So once again, we're maximizing. The modern closet takes 4 hours to make, and the antique closet takes 8 hours to make. The company has 80 hours available to make these closets. The company can make at most 14 closets. Claire's company can sell a modern closet for $12 and an antique closet for $20. How many of each closet should they make to maximize profits, and what is their maximum profit? So you can see when we get a problem in this section, it's much more overwhelming than what we just saw because it's one word problem with all that information. So it's important that you break down a few things. First of all, you're going to look for the different constraints. This one's going to talk about time, number of closets, and it's always going to have real world, but then you also have to identify your variables. So when I look at this problem, I notice that we're talking about 2 different types of closets. So I'm going to call the modern closet X and the antique closet Y. So I always like to read the problem once, kind of figure out what my constraints are, figure out what my variables are, and then I go back. And now this time, I'm going to underline anything that's about time, squiggle under anything that's number of closets, and I can't forget, ultimately, I care about profit. So I'm going to put a box around anything about that. So Claire Dunphy decides to have her company make new closets to maximize her profits. The modern closet takes 4 hours, so that's a time, and the antique closet takes 8 hours. So right now, and they have a total of 80 hours. So right now I can write an expression for that. I can take 4x, because it takes 4 hours for the modern, plus 8y, 8 hours for antique. And if I only have 80 hours, it means this must be less than or equal to 80. Okay? And then I keep reading. It says the company can make at most 14 closets. So that's talking about number of closets. But that's the only thing they say about that. So that means the combination of modern and antique. So that's just x plus y. Sometimes that's the hard one for students just because there's not as much information about it. But if they can make at most 14 closets, those two combined have to be less than or equal to 14. Once again, the real world constraints, x is his number of closets. So I can't make negative closets, so x has to be greater than or equal to 0. And y is the number of antique closets, so once again, y is greater than or equal to 0. So now our goal is to take these 4 inequalities and graph them. Well, x is greater than or equal to 0. Remember, be a vertical line here, and we shade everything to the right, which means the first quadrant. Y greater than or equal to 0 would be here. Everything there. Okay? Now, again, this axis is the modern closets. This one is the antique closets, because that's my y-axis. All right, so I do like to convert these into slope-intercept form, and for the sake of time, I'm just going to tell you what I got. This goes to negative y is less than or equal to negative 1/2 x plus 10. Okay, so at 10, 1, 2, 3, 4, this is 5, 6, 7, 8, 9, 10. And then I go down 1 over 2. Now, it is important. The reason I switch it to slope-intercept form is because these critical points are important. Because remember, our whole goal is to find the point of intersection. Okay, so this is the first constraint. When I plugged in 0, I got is 0 less than or equal to 10? Yes, which means I shade down here. Okay, when I solve this one, I get y is less than or equal to negative x plus 14. 11, 12, 13, 14 is right here. And then I go down 1 over 1. And again, I need exact points, which is y. So this is a critical point. Keep going. And this is a critical point. So that's my one. Is 0 less than or equal to 14? Yes. So once again, shade down, which means this region right here is my feasible region. And I need the 4 points of intersection of that, 3 and 4. And so what they are the point 0, 0. This one's at 0, 10. This one you could count it out, but is at 14, 0. And this one was at 8, 6. So you do have to be accurate. Now, last but not least, we need to find the profit equation. And it says a modern closet sells for $12 and antiques for $20, which means my profit equation is 12x plus 20y. So I multiply all of my x values by 12 when I do my math, and add them to all my y values multiplied by 20. Okay, so I show that work. You don't have to put that in the table. You can just do it in a calculator. But 12 times 0 plus 20 times 0 is obviously 0. 12 times 0 plus 20 times 10 gave me 200. 12 times 14 plus 20 times 0 gave me 168. And last but not least, 12 times 8 plus 6, or 20 times 6 gave me $216. So again, this combination gives me my maximum profit. So to maximize my profit, you should make 8 modern closets and 6 antique closets. So you can see how you'd use this as a business owner to make sure that you're making your most money possible. There is a second video that shows the 2 examples on the back that you can watch next for more practice. Thanks.